In this example, we hope to apply the homogeneity property. We are told that the weight of a certain type of fish is the power function of its length. The value of the power in this function is k equals 1.09. So the way that I work through this problem is that I know that if the input is changed by a factor, then the output is that factor to the k power. So it tells me here if the length is doubled. So this length is input. And if doubled would be times 2. So the input is being multiplied times 2. So what I'm going to do is I'm going to take that 2 and I'm going to apply the exponent 1.09. And I'm going to put that on my calculator. So 2 to the 1.09. And I have 2.129. 2.129. You could have rounded that differently, and that would be totally fine as well. And so what is this telling me? This is telling me that it's 2.129 times, and I'm looking here at the output is the weight, so times heavier. All right, so the next one tells me if the length is halved. Okay, so the length is the input. So we're taking the input halved would be times 0.5, so times 0.5. So that factor for the input is 0.5, and the exponent for the function is 1.09. And so I do that on my calculator, 0.5 to the 1.09, and I get 0.46. Oh, the 9 rounds up. Let's just go with 0.47. So 0.47 times the original, or times as much, or times heavier. It's really lighter, so times as much makes most sense to me. So this is saying if the fish is half as long, its weight is a little less than half of the other one, because it's only 0.47. Now, you may be thinking, how do I know what's input and what's output? Some of it is the wording. In the wording, weight comes first. So if I modeled that with an equation, that means weight would come first, and then equals. It says the power function of length, so I would say there's some constant, which I don't know, times the length. So use L for length. And it's the power function of length. So length is the one that has the exponent of 1.09. So that's why every time that the length was doubled or the length was halved, I applied the exponent to know what the overall impact on the problem is.